Welcome. So here in this video I am going to talk about some problems related to the topic of relation, pigeonhole principle and other related topics. So to get better out of it, I would suggest you to watch the video till the very end. In case if you are coming across this video for the very first time, and if you are new to the channel, please do subscribe it because it will help you to get good quality video content. So let's start. So what is the first problem? A drawer contains 12 red and 12 blue socks, all unmatched. A person takes out at random in the dark, takes socks out. How many socks he should take out to be sure that he has at least 2 blue socks? So I think to solve this problem we are going to look at the worst case scenario. They are asking that how many socks he should take out to be sure, and that is important observation. So let us consider the first situation where he takes the first 12 socks out, and suppose all of them are red, 12 red, right? So it is a worst situation, right? Now suppose he takes the 13th socks out, then in that case it must be a blue socks. Now to get a pair of blue socks, or at least 2 blue socks, he must have to take 14 socks out to guarantee that he will have at least 2 blue socks. So the correct option will be A. I hope you got it. I repeat it quickly. In the beginning, suppose someone takes out 12 socks, and it may happen that all of them are red socks, right? So to guarantee that he gets at least 2 blue socks, he has to take 14 socks out of which 12 may be red and the remaining 2 will be the blue socks. Now this is also a good question. How many numbers must be selected from the set to guarantee that at least one pair of these numbers add up to 7? So first of all, if I take this 6 number, and if I ask you that how to collect pairs which will add up to 7, so if I take 1, then the next element should be 6, so that 1 plus 6 will be 7. If I take 2, then the other element should be 4, so 2 plus 4 will be 2 plus 5. Let me remove. I was thinking of 6. So the other element should be what? Other element should be 5. So 2 plus 5 will be 7. Third possibility is that I can select a 3 and 4. So 3 plus 4 will also add up to 7. So suppose I again talk about the worst case scenario, that in the first 3 picks, suppose I got 1, then I got 2, and then I got 3. So this is the first 3 picks, right? I am selecting the first 3 number, and I am selecting first number from this pair. So I got 1, then this 2, and then this 3. Now if I select any fourth number, right, so either I have to select 6 or 5 or 4. So means the first 3 numbers, if I am selecting from any of these pairs, I could have selected 1, 2 and 3, or I can select 6, 5 and 4. This is the worst case scenario, that someone is picking the number. First number he got is 6, the second number he got is 5, third number he got is 4. None of them are adding up to 7. Or another possibility was that he got 1 or 2 or 3. So these are also not adding up to 7. But the moment he will select the fourth number, it must be from any of these 3 pairs. So that fourth number, if I, for example, if I select the number 5 here, so in that case 2 plus 5 will become 7. If I, for example, select 4 here, then 3 plus 4 will become 7. If I select 6 here, then 1 plus 6 will become 7. So minimum number of element that he should select so that at least one pair add up to 7 is equal to 4. I hope you got this problem. Now this is a memory based problem, no need to discuss much. The number of subsets of A cross A is, and here one thing I think in the original statement also they missed, since this is not mentioned that how many elements are there in A, but if I look at the option, it looks like the number of elements in A is equal to n. Ideally, it should have been mentioned that number of elements in A is equal to n. So A cross A will be having how many elements? It will have n square element. So the total number of subset of a set with n element is 2 to the power n. So total number of subsets with a set with n square element will be 2 to the power n square. So the B option will be correct. This is also a good question. How many friends are there in a group of 267 people who have an identical number of friends in the group? And be careful, I will be explaining it very slowly so that you understand it. Suppose I say that out of the 267 people, each of the person has at least one friend. Each of the person has at least one friend, right? Now if each of the person has at least one friend, then this any person, if I select at random, what are the possibility? That person, suppose I select the person X, so that person may have one friend, two friend, or 267 minus 1, 266 friend, because I am saying that each person has at least one friend. So suppose I select any random person X, that person may have one friend or two friend or 266 friend. Everyone other than this X, and X will have all other people as his friend. So now if I look at this situation here, the X may have the possibility. What is the possibility for X? That X may have one friend, X may have two friend, or X may have 266 friend. So I can consider this 266, 1 to 266 as 266 different wholes, right? Let us consider them as wholes. And how many people are there? We have 267 people. So let us consider them as pigeons. So now these 267 people, 267 pigeons have how many holes? Have 266 holes to occupy. So using the pigeonhole principle, I can say that there will be at least one hole which will correspond to more than one pigeon. So minimum number of friend or identical number of friend, because these boxes are representing what? These boxes are representing the number of friends a person may have. So the number of friends a person may have vary from 1 to 266. So these are corresponding to holes. How many pigeons are there, which are the number of people? These are 267. So at least one hole will be there. Suppose I say this hole is there, which will be filled by more than one pigeon or more than one people. So these two people will have identical number of friends. So what is the answer here? The answer here is C. This is slightly, engaging problem. So I hope you have understood. Another important point is that you may ask that why you are selecting that at least one friend is there. Suppose you select another possibility that there is a guy who does not have any friend. So in that case, you can remove that guy. So you will have remaining 266 people. And now since this person has not any friend, the same principle can be applied on the remaining 266 people. Again, you will be able to reach to the conclusion that there will be at least two people in the group who will have identical number of friends. So the correct option is C. Now let us look at this problem. Let A has the element 1, 2, 3, 4 and R is the relation defined on A. Then which of the following option is correct for R? So R is reflexive. Is it true? This R contains 1, 1, and this R contains 2, 2, this R contains 4, 4, but this R does not contain 3, 3, so R is not reflexive. Is it symmetric? R contains 4, 3, but R does not contain 3, 4, so it is not symmetric as well. Is it antisymmetric? R contains 2, 3 and 3, 2 both, means it is not permitted in antisymmetric relation. If xy is there, then yx should not be there. So this is also not antisymmetric. Is R transitive? So to check that, we have suppose take the elements like here we have 3, 2 and rather suppose I take the element 2 comma 3. I take 2 comma 3 and I take 3 comma 1, right? I hope you can see we have an element 2 comma 3 and we have element 3 comma 1. So if 2 comma 3 is there and 3 comma 1 is there, so for this to be transitive we should have element 2 comma 1, but 2 comma 1 is not there, so this is also not transitive. So the question is that which of the following option is correct for R? So none of this. It is neither reflexive nor symmetric, it is even not anti-symmetric and not transitive, so means none of the option given is correct here. Okay, now let us go to the next question. Let R be a relation which is like x comma y, and the element x comma y belongs to R if x is greater than y, and the relation is defined on the set of real numbers. Then which of the following option is correct? R is transitive. So if I say x comma y belongs to R, so this implies what? This implies x is greater than y. And if I suppose y, I say y comma z also belongs to R, so this implies that y is greater than z. So from these two we can conclude that x is greater than z. So it means what? That x comma z also belongs to R. So certainly this is transitive. And is it anti-symmetric? Since x comma y belongs to R, this implies x is greater than y. And if x is greater than y, then certainly y can't be greater than x. So if x comma y belongs to R, then y comma x does not belong to R. So it is anti-symmetric also. So R is transitive and R is anti-symmetric both. So which option will be correct? Both 1 and 2 option is correct here. I hope you are getting. Now let us look at this problem. So here R is defined as it contains all those ordered pair x comma y for which x is less than or equal to y, and it is defined on the set of real numbers. So which of the following option is correct? So clearly x is related to x for all x in the set of real number, right? If I take the domain as set of real number, because x is less than or equal to x for every x is less than or equal to x is true. So all elements of type x comma x belongs to R. So it is reflexive, right? It is reflexive. There is no doubt about it. Now is it symmetric? So suppose I take element 2 comma 3. So 2 comma 3 belongs to R, the relation R, because since why? Because 2 is less than or equal to 3. But 3 comma 2 does not belong to R. Why it does not belong to R? Because 3 is not less than or equal to 2. So it is not symmetric. R is reflexive but not symmetric. So which of the following option is correct for R? Only one. Yeah, only one is true because symmetric is not true. Both 1 and 2 is certainly not true. So the correct option is A. This is a important question here, that let A be the set ABC and R is the relation defined on it. Then which of the following option is correct for R? So R is transitive because AA, BB and CC are there. So there is no such thing like x comma y and y comma z, right? When we check the transitivity, what do we check? That if x comma y belongs to R and y comma z belongs to R, then x comma z should belong to R. That is the requirement, right? But here there is no such element, so certainly the transitivity requirement is okay here. And is it symmetric? So for symmetric also, it is kind of elements, like if we have element like x comma y is in R, then we need to have y comma x in R. But here we notice that we have the elements like a comma a for which a and b are equal, so it is symmetric also. So R is transitive, R is symmetric, so both 1 and 2 are correct. Even though it is not asked in this, you can also say that it is reflexive. So R is reflexive also, it is symmetric also, it is transitive also. So in some of the question they may ask you that whether it is an equivalence relation. So the answer is yes, this is an equivalence relation. And when I define a relation of this kind on a set where we just take elements like AA type or XX type, then that relation will be equivalence relation if all XX are there for every element that is there in the set, right? So this option C will be correct here. Okay, so now let us look at this problem. And here the problem is that the relation of divides on the set of positive integers is, and this is a kind of very popular question. I think you must already have guessed the answer, that if I take the set of positive integer z plus, and on that if I define the divisibility relation, this relation is certainly reflexive because every element A divides itself. I am taking only the positive integers, like so 1, 2, 3 and up to infinity, and so it is reflexive. This relation is reflexive, no doubt about that. If A divides B, then B can't divide A unless A and B are equal. So this is anti-symmetric. Right? I hope you have already understood that this is not symmetric, because suppose for example I say 2 divides 4, but 4 does not divide 2. So this is not anti-symmetric. This is reflexive. Sorry, this is not symmetric. This is anti-symmetric, which we already have seen. And whether it is transitive, we know in general that if A divides B and B divides C, then certainly A will divide C. So this is a transitive relation also. So this relation is a reflexive, anti-symmetric and transitive. So this is a partial order relation, and it is a very popular question. I hope you already know this answer. Now this is a memory based question. One suggestion I would give you, that in case if you have not watched my video related to counting the number of relation, and if you don't have much time, at least certainly you should watch the last few minutes of that video. Whenever you get the time, please watch the whole video, because counting the number of relation is a very important thing. And to find that video, first of all you have to access the playlist of relation, and in that you can find out that counting the number of relation is a video that I have uploaded. But here, to solve this question, if A has 5 elements, then the total number of reflexive relations defined on A. So the number of reflexive relation defined on a set with n element is given by 2 to the power n square minus n, and this you have to remember. So if I have 5 element, I will take 2 to the power 5 square minus 5. So that will be equal to 2 to the power 25 minus 5. So that is equal to 2 to the power 20. So the correct option will be C. This is a kind of memory based question. I hope you remember the different types of relation and the number of relations that are possible on a set with n elements. Now let us look at this question. Suppose that the relation R on a set is represented by a matrix. We have seen earlier also that the relation can be represented using directed graph or matrix. So this is the matrix representation of a relation, and then they are asking that which of the following option is correct for R. So first one is R is reflexive only. Now you know that for a relation to be reflexive, its matrix representation should have all 1 along the main diagonal. So here you have 1, here you have 1, but here you have 0. So this is not reflexive, because for the matrix for the relation to be reflexive, the matrix should have all 1 along the main diagonal. So this is not reflexive, right? Now let us check whether it is symmetric or not. So for this to be symmetric, the matrix and its transpose should be same. So what is the transpose of this matrix? The first row is 1 1 0, so first column will be 1 1 0. Second row is 1 1 0, so second column will be 1 1 0. And third row is 0 1 0, so third column will be 0 1 0. So are these two matrices same? Because for the relation to be symmetric, the matrix representation should also be symmetric, right? So you have here you see that the 1 1 1, but here you have 1 1 0. So it is not symmetric, right? Because the transpose of the matrix is not equal to the original matrix, so it is not reflexive and it is not symmetric as well, right? I hope you understood this question. The idea is that for the matrix to be reflexive, it should have all 1 along the main diagonal, and for the matrix to be symmetric, the matrix rather for the relation to be symmetric, I am using it interchangeably. Let me rephrase my statement to avoid any confusion. If the relation is symmetric, then its matrix representation will be a symmetric matrix. But this matrix is not a symmetric matrix, so it is not symmetric also. So what will be the correct option? R is reflexive, R is symmetric, both no. So this option will be correct, D. Next question. And here there are actually two questions in this. So let us answer them one by one. And this is an important question. So let me to answer both of these questions, the question this and this, I am going to first draw the Hess diagram, because to answer this kind of element it is easier to answer if you can draw the Hess diagram first. So how do you draw the Hess diagram? So here you have the element 2, and then 2 divides 4, so you write 4 here and you draw this line, and here this is the divisibility relation. And then you have the element 5, and 5 divides 10, so you write 10 here. So 5 divides 10, and 2 also divide 10, so you join that. And then you have 12, so 4 divides 12, so you write the 12 here, right? And then you have 20, so 10 divides 20, so suppose you write 20 here and you join them. And then you have 25, so you write 25 here and you join them. I hope you know how to draw the Hess diagram. So we have the elements 12, 20, 4, 10, 2, 5 and 25. So 1, 2, 3, 4, 5, 6, 7, and here 1, 2, 3, 4, 5, 6, 7. I hope I have not missed any of this. So 2 divides 4, 2 divides 12, 2 divides 10, 2 divides 20, 2 does not divide 5, 2 does not divide 25, 5 divides 10, 5 divides 25, 5 divides 20, and I think, yeah, one more thing I am missing here, that 4 divides 20 also. So this is, I think, is the correct Hess diagram. Now if you look at this Hess diagram, you have to answer that which of the elements are maximal element and which of the elements are the minimal elements. So the first is, what are the maximal element? And as you know the definition of maximal element, the definition is that it should not be less than any other element of the poset. So the maximal element are 12, 20 and 25. Don't miss that. Don't consider that it is at a different level, so it is not a maximal element. 12, 20 and 25 are the maximal element, because 25 is not less than any other element. Similarly, 20 is not less than any other element, and 12 is also not less than any other element. The next question is that which of the elements are the minimal elements, and you can clearly see that elements 2 and 5 are the minimal elements. So both 2 and 5 are the correct answer for the minimal element. I hope you have got the answer. Now the question is that if the relation is division, then the poset this the greatest element is and the least element is. Now to answer this question, I want to look at the Hess diagram that I have drawn here, and then I will move and let us decide the answer here only. So what are the greatest element? There is no greatest element. There is no element which is greater than all other element, right? So you can see the partially ordered set or Hess diagram here. There is no greatest element, because 12 is a maximal element, but 12 is not greater than 20, 12 is not greater than 25. Similarly, for 20 and 25 also you can argue. So there is no greatest element here, and similarly there is no least element as well, because 2 and 5 are the minimal element, but between 2 and 5 there is no relation. We can't say whether 2 is means 2 and 5 are incomparable or non-comparable element. So you can't decide between 2 and 5. So the correct option here for this question will be that what is the greatest element? So the answer is does not exist. And what is the least element? The answer is again does not exist. Now this question will be slightly more engaging, so be careful, and I want to answer this. To answer this, first of all I need to draw the Hess diagram. And to draw the Hess diagram, first let me take the element 2 here, and here also we are taking the divisibility property. So 2 divides 4, right? So I will write 2 divides 4, and then 2 divides 6 also. So let me write 6 here, right? This is kind of going to be slightly time consuming, but since it is an important concept I am discussing it, so don't worry. So 2 divides 6, and then we have 9, right? So let me write 9 over here. Now we have 12, so I can write 12 over here because 4 divides 12 and 6 also divides 12, so we have to join them. And then we have 18, so 18 I can I think write over here because 18 is divided by 9 and 18 is divided by 6 also, so this is how it will look like. Now we have 18, we have 27. So 27 I can join, like suppose I draw 27 over here, there is no harm. So I can join this 27. Okay, and there is like which element, 36. So if I write 36 over here, 18 divide 36 and 12 also divide 36, so I can join this. Right, it is not like you also need to draw, but the idea is that it should follow the properties of it, the properties of the Hess diagram, which you draw for any partially ordered set. And then 48 is there, so 48 will come over here. 48 is divided by 12, so 48. And we have 60 also, so 60 is divided by 12, so let me draw 60 over here, and 60 is divided by 12. And finally 72, so if I draw the 72 here, there is no harm because 72 is divided by 36. Let us verify. I want you to verify this, don't just follow me. I want you to verify that whether you agree to this arrangement that I have drawn or not, right? So let us verify quickly and then I will answer the question. Now the question that I need to answer here is what are the lower bounds of the subset 60 and 72. So 60 is the element here and 72 is the element here. So let us look at the lower bounds. Is 48 a lower bound? No. So 48 is not a lower bound because 48 is not dividing 72 or not, neither 60. Is 36 a lower bound? No, because 36 divides 72, but it certainly does not divide 60. Is 12 a lower bound? Yes, 12 is a lower bound because 12 divides 60 also and 12 divides 72 also, because here it is transitive property. 12 divides 36 and 36 divides 72, so 12 divides 72. So 12 will be a lower bound. So 12 is okay. What about 18? So 18 divides 72, but 18 does not divide 60. There is no direct path from 18 to 60, so 18 is not there. So 18 I don't consider. Similarly 27 I don't consider. You can clearly see it is neither dividing 72 nor 60. What about 4? So 4 divides 12 and 12 divides both 60 and 72, so 4 should be considered, right? 4 will be a lower bound. 6 will also be a lower bound because 6 divides 72 and 6 divides 60, so 6 should be there. And if 4 and 6 are there, then certainly 2 should be there. What about 9? 9 can't be there because 9 does not divide 60. So 9, 27, 18, 36 are not there. 2, 4, 6, 12 and are the elements which are the lower bound. So for this, what are the lower bound of the subset? So the lower bounds are 2, 4, 6 and 12. I hope you remember the definition of a lower bound. An element will be a lower bound if it is less than or equal to all other elements, elements of that set, subset. So 2 is less than 60, 2 is less than 72. And don't get confused with the term that I am using, less than or equal to. I think you understand that when I am defining the ordering, an element A is less than or equal to B if A is related to B. I believe that you have understood the concept and then you are watching the video. If you have not, please watch the post video that I already have uploaded, right? So this is a slightly time consuming question, but since it is answering multiple questions, so this kind of question may be asked. So now let us move to the next question. Okay, so let us look at this problem, and it is a similar problem to the previous one. The only difference is that in this they already have drawn the Hess diagram for us, right? So they are asking what are the upper bounds of the subset ABCD. So this is the element A, this is the element B, this is the element C, and this is the element C. D. Now if I look at this poset or this Hess diagram, so what are the upper bounds? First of all, let us look at the element E. So E is greater than C and A and B, but not greater than D. So E can't be an upper bound. I hope you understand this. E is greater than B because BE is there, CE is there, and AE is also there. So, but it is not greater than D, so that is why E can't be taken. What about G? G is greater than A, B, and D, but not greater than C. So G is also not an upper bound. What about F? F is an upper bound because F is greater than D, F is greater than B, F is greater than A, F is greater than C. And since F is an upper bound, then J and H are also an upper bound. So we have got three elements, F, J, and H. What about the element D? D is greater than B, A, and D is related to D also, but D is not greater than the C. So the correct option will be F, J, and H. I hope you have understood the answer or explanation. In case if you have not, please put your doubts in the comment section. Next question. Now, which of the posets represented by the following Hess diagram has a greatest diagrams have a greatest element? So certainly this does not have a greatest element because we can't compare. These are non-comparable element B, C, and D. So this can't be true. Here also there is no greatest element because D and E are non-comparable. So this is also not true. Here D is the greatest element because it is greater than all other elements. So this option is, this is a possible poset. And here this is also D is the greatest element because D is greater than all other elements. So these two, C and D, both have the greatest element. So which of the option is correct? The question is which of the following poset have a greatest element? So both C and D have a greatest element. So the option A is correct. Okay. Now this is again a important question, that which of the following poset with the Hess diagram are lattice? And I hope you remember the definition of a lattice. What is the definition of a lattice? A partially ordered set is said to be a lattice if every pair of element has a least upper bound and a greatest lower bound. Now I leave this for you to verify that if you take any pair of element in the first, you will be getting a least upper bound and a greatest lower bound. I am not going to verify this. I leave this for you to verify. Here I am just going to look at this option and going to show you that this is not a lattice, right? And to show you that this is not a lattice, I have to find at least one pair of element for which either the least upper bound is not there or the greatest lower bound is not there. So let us take the element here B and E, right? If I take the element B and E, what are the upper bounds? What are the upper bounds of B and E? So the upper bounds of B and E are F, G, and H. I hope by now you are clear about how to find the upper bounds. So there are three upper bounds, that is F, G, and H. D is not an upper bound because D is greater than B, but D is not greater than E, right? So F, G, and H are upper bound. Now the important observation here is that among these three, F, G, and H, which one is the least upper bound? I hope you understand the concept of least upper bound, right? So you can clearly see that elements F and G are incomparable element. You can't compare. You can't say that F is less than or equal to G. No, it is not true. Neither G is less than or equal to F. It is also not true. So F and G are non-comparable elements. So for element B and E, there is no least upper bound. The upper bounds are F, G, and H, but there is no least upper bound. So this is not a lattice. So this is not a lattice. Not a lattice. Right. I leave this for you to verify that this is a lattice. So what is the correct option? Correct option is only poset A is a lattice. Okay. Now this is another interesting question. Okay, so let us see this problem. The minimum number of students required in a class to guarantee that at least 8 will score the same grade if there are 5 possible grades A, B, C, D and E. So this is a problem related to generalized pigeonhole principle. And in case if you have idea about generalized pigeonhole principle, you might have seen that the n is the number of object, k is the number of boxes. Then there will be at least one box which will contain at least n by k, and this symbol that I am using is for the least integer number. So here this n by k should be equal to 8, right? That is the question. And what is n here? The n here is something that we need to find. And what is k? The 5 possible grades. So this is A, B, C, D, E. So by 5, and that should be equal to 8. So what should be n? N should be equal to 5 into 7 plus 1. Because if I take 5 into 7, then 5 and 5 will cancel. I will get this is equal to 7. But if I take 5 into 7 plus 1, means if I take n is equal to 36, then 36 by 5, if I take the least integer function value of this, it will be 7 point something, so this value will be equal to 8. So the correct option here is B. This is a kind of good question. I hope you have understood this. Now let us go and solve this next question here. Now this is a interesting question, and it will be slightly time consuming also. So listen it carefully, because there is a scope of getting confused. So they are asking the number of equivalence relation containing 1, 2. So if I define any relation R, let me first call it R1, on any set which are having 3 elements 1, 2, 3, then certainly it should have 1, 1, 2, 2 and 3, 3, because the equivalence relation must be reflexive. So this is the must kind of element. Now they are saying it should contain 1, 2. So if I add 1, 2, then for this to be symmetric, it should also have 2, 1, right? Now this relation you can verify is an equivalence relation because it is reflexive and it is symmetric. It is transitive also, because if I take 1, 2 and 2, 1, then 1, 1 is there. 1, 1 and 1, 2 is there. So 1, 2 is also there. So you can verify that this is transitive also. Now let us write the next equivalence relation. So 1, 1, 2, 2, 3, 3 is required. 1, 2 should be included because they are asking me to count those equivalence relations which contain 1, 2. So because of 1, 2, 2, 1 should also be there. Now what are the elements which are left? If I talk about A cross A, there are 9 elements. So other than these 5 elements, what are the elements left? Elements left are, let me write 1, 3, 1, 1, 1, 2, 1, 3, then 2, 3, then because we have 2, 2, 2, 3 should be there, and 2, 1 is already there. 3, 1, right? 3, 1 is not there, so 3, 1 is missing, and 3, 2. I hope you got this point, because in A cross A, how many elements will be there? There are 9 elements, and here you have 5 elements already listed. So what are those missing 4 elements which are not listed from this A cross A? So 1, 3, 2, 3, and 3, 1 and 3, 2. Now suppose I try to write another equivalence relation. So I need to add some more element. So suppose I add 1, 3. So the moment I add 1, 3, for this to be symmetric, I also need to add 3, 1, right? And 1, 3 and 3, 1 is there. Now next thing that you need to check, that is it transitive. So you notice one thing here, that you have 3, 1 and you have 1, 2. You have 3, 1 and you have 1, 2. So for this to be transitive, it should also have 3, 2. Otherwise, if you just add these 2 elements and close it, it won't be transitive. I repeat it, 3, 1 is there, and 1 comma 2 is there. So for this to be transitive, 3 comma 2 should be there, and since 3 comma 2 is there, for this to be symmetric, again 2 comma 3 should be there. Now we already have listed all the 9 elements which are there in A cross A. You can count it, 4 and 5, 5 and 4, 9. So now this is another equivalence relation. So as you noticed that this was an equivalence relation, and another equivalence relation is the whole A cross A. So only 2 equivalence relation are possible. So this is the correct answer. This is a slightly more engaging problem. Please think about it and convince yourself that the argument that I have made is making sense to you. In case if you have doubt, put it in comment box. Suppose A is a finite set with n elements. The number of elements of the largest equivalence class of A are. So we just have seen that if A is a finite set with n element, then A cross A will have how many elements? It will have n square element. And the largest equivalence relation that I can define on A, that I am going to take all elements of A cross A, right? So it will be like n square. So the correct option will be B. Like you see the previous question, if I take all the 9 elements, that will be an equivalence relation, and that will be the largest, because in A cross A we have n square element, so that will be the largest one. Now let us look at this question. The real number, for real numbers x and y, x is related to y if x minus y plus root 2 is an irrational number. Then the relation R is, so first of all, x is related to x. Why? Because x minus x plus under root 2 is, this x and x will cancel, it will be equal to under root 2, and this is an irrational number, and this will be true for any real number x. So there is no doubt about this. X is related to x because x minus x plus root 2 is equal to root 2 is an irrational number. So this is certainly reflexive because every x is related to itself. So this is a reflexive relation. And since we have just one correct option, so this is reflexive, I will tick. But just to make sense to you, it is not symmetric, because if I take 1 comma root 2, 1 minus root 2 plus root 2 is not in R. This will cancel and this will be equal to 1. So this is not an irrational number. But root 2 comma 1 is an irrational number, because root 2 minus 1 plus root 2 is equal to 2 root 2 minus 1. So this is an irrational number. So this is not symmetric. Similarly, you can verify that this is not transitive as well. So the correct option is reflexive.